Alright guys, we're still looking at quadratics. Remember, a quadratic is something squared. So anytime you have a function with x squared, that means it is a quadratic, if the x squared is your highest term. Alright, so now we're going to look at transformations of quadratics. And transformations are all about how things change. Alright, so they may be a shift, they may be a dilation, they may be a reflection, but it's all about how they change. Alright, let's look at the basic quadratic function. So we looked at this before, and that's going to be ax squared plus bx plus c. Alright. We refer to this as standard form. All right, we're going to analyze transformations on this basic equation in vertex form. So instead of looking at standard form, we are going to look at vertex form. So vertex form is f of x equals a times x minus h squared plus k. Alright, so h is going to be your horizontal movement. Okay, so it's going to move to your blank if h is added to x. Alright, so if something is added, it's going to move to your left. And it's going to move to the right if h is subtracted. Alright, so this kind of seems opposite of what you think, but it's because it's x minus h, so x opposite h. Okay? Alright, your vertical translation is k. K is going to move you blank units if k is positive, so it's going to move you up k units if k is positive, and it's going to move you down k units if k is negative. Okay? Alright, it's going to open up if a is positive, and it's going to be a reflection down if a is negative. Alright, so a tells you whether it goes up or down. Up means a is positive. If it's turned down, a is negative. Alright, if a is greater than 1, it's going to be a stretch vertically. And if a is between 0 and 1, it's going to be a compression. Alright, make sure you pause this, take good notes, and then when you're ready, go ahead and move on. Alright, so let's look at some examples here. It says graph and state the transformation of y equals x squared. So y equals x squared is your parent function. You can see that is graphed here, and this is the transformation of that function. Alright, so if you look at this function, the vertex, we just looked at vertex. The vertex comes from h and k. So your vertex is 5, 3. And the axis of symmetry is whatever your x is, so x equals 5. Alright, for this, we want to see what this does. So this is going to be, it's going to move you right 5 units. And it's going to move you up 3 units. Alright, so the next one is going to have a vertex of 4, 0. There's no k this time, so it's just going to be 0. And your axis of symmetry is whatever the x is. Alright, so this time it's going to be a reflection because it's negative. So it's going to reflect across the x. Alright, it's going to be a stretch of 2. And it's going to have a movement to the right, 4. All right, go ahead and make sure you pause this, make sure you get everything you need, and then move on when you're ready. All right, the next example. All right, it's got 1/2, so that's going to be a compression of 1/2. And I forgot to write down the vertex, all right? So it's going to be opposite h, so -6, -3, axis of symmetry, x equals -6. All right, so a compression of 1/2. The +6 is going to move it left 6 units. And the -3 moves you down 3. All right, it says, recall that a quadratic function in standard form can be written f of x equal ax squared plus bx plus c. The vertex form of a quadratic function is given f of x equals a times x minus h squared plus k. We will now apply the concept of completing the square to convert a standard form function to its vertex form. All right, so if you remember, completing the square is the process of making your polynomial, making your quadratic into a perfect square so it will factor. So if I take this and I say x squared minus 6x plus blank, and then I'm just going to move the -5 over, and if I plus something and subtract the same something, then I'm not changing the problem. All I'm doing is manipulating the problem. So what do I want to put here? When you complete the square, you take this number, you half it, and you square it. So I'm going to take -6 and half it. -3 square it is 9. So I'm going to add 9, and I'm going to subtract 9. All right, why did I do that? Because now this is a perfect square trinomial. Remember, we did the special factors. So now I can go straight to x minus 3 squared. -5 and -9 make -14. And you can see that this is now in vertex form. All right, so that's all it is to it, to go from standard form to vertex form. All right, it's a little bit more difficult when you have a number, your coefficient is up front, but we do need to make a note that a is 2. So whether it's in standard form or vertex form, the a will be the same, okay? All right, so to use completing the square, we have to first divide everything by 2. We have to have a coefficient of 1 in order to completing the square. So we're going to have y equals x squared. 8 divided by 2 is 4x. And then 7/2, we'll just leave it as 7/2. All right, so now we're going to do plus blank. I'm going to have 7/2, and I'm going to do minus blank. And again, I just put the blanks there to remember that I have to add and subtract the same number. I can't, if I forget to do this, then I've changed the problem. But if I add and subtract the same thing, then I haven't changed the problem, just manipulated it. All right, so I'm going to take 4. I'm going to half it, which is 2. 2 squared is 4. So I'm going to add 4 to both sides. And now these first 3 make up a perfect square trinomial. So it's going to be x plus 2 squared. And then I need to add 7/2 and -4. So if I put this over 1, change this to a common denominator by multiplying top and bottom by 2, I've got 7 minus 8. 7 minus 8 is -1 over 2. And I don't need a negative twice. Let me see. All right, now the only thing I have to remember is that I factored out a 2, so I have to put a 2 back. So So I have to put a 2 back all the way with the whole problem. Okay, so if I factored out a 2, now I'm going to have 2 times x plus 2 squared, and then 2 times negative 1/2 is negative 1. And my pen always decides not to work. I don't know why. Alright, so this is basically the same process. It's just a little bit more complicated when there's a number in front that you have to divide by. So again, divide by whatever the leading coefficient is. That way you've got only x squared. Then you can go straight to perfect square trinomial. You can factor that, and then you can just multiply the a back in. Alright? If you have any questions with that, please let me know. That is an important standard in math too. Alright, the last thing, you need to be able to generate a quadratic in vertex form given a vertex and a point. Alright, so if we're given a vertex and a point, alright, your vertex is negative 4, 3, and you're given a point, negative 3, 6. Alright, so this is h and k, and this is x and y. So if you plug it into this formula, you can say 6 equals a times x is negative 3 minus a negative 4 makes that plus 4 squared plus 3. So all I did was plug these in here so I can solve for a. Alright, so I've got 6 equals, this is 1 squared, so 1a plus 3 minus 3, so a equals 3. So if you have a and you have a vertex, then you just write it in vertex form. So vertex form is going to be y equals 3 times x minus a negative makes that plus quantity squared plus 3. And that is vertex form for this quadratic function. Alright, so there's a few examples to help you out. If you have any questions, didn't mean to lose the page there. If you have any questions, please let me know.